cgroups is an infrastructure to manage and control resources on a computer. Something that computers have always been very good at doing is sharing their system resources among all the applications running on them. However, as we all know, sometimes some applications are more important than others and you'd like them to have a larger share of the resources. cgroups offers a mechanism whereby a system administrator can control and allocate how many resources on a computer each application gets. So let me show you an example of how this works. Let's imagine we have a corporate web server and a personal web server, each running on their own VM guest on a shared host with a shared network link. If we start sending network requests to the corporate web server, we can see that it monopolizes the shared network link, coming to about 700,000 kilobytes per second, which is about 90% of the available throughput on a 10 gigabit network card. If then we begin sending requests to the personal web server, which remember is on a shared bare metal host, we'll see that the bandwidth available on the shared 10 gigabit link gets shared between the two VMs at about 50% utilization each. That's not always desirable. A corporation might like to be willing to, for example, pay to have extra bandwidth or extra availability on their server. cgroups lets us do this. By creating resource groups within the cgroup file system, we're able to tag each VM guest with an ID and then use the filtering capabilities of the Linux network stack to dole those identifications, which are representative of traffic from each VM, to a separate quality of service. If we implement this policy, we'll see that once we do, our corporate web server returns to its previous 90% utilization value at around 700,000 kilobytes per second, while the personal web server is reduced to about 5% of the total network bandwidth, or about 500 megabits per second. Let's take a look at another example. This time, instead of allocating network bandwidth, we'll be allocating disk bandwidth. Here you can see we have two Oracle databases running, against which we're running database benchmarks. As you can see, both databases are equally sharing the disk throughput at approximately 50% utilization. However, it would be very nice if we could prioritize our high priority database over a lower priority database. Again, cgroups gives us an opportunity to do this. By creating two resource groups and limiting the amount of disk bandwidth that one can use while granting the other a larger percentage, we're able to see on the graph that as we implement this policy, our high priority database is able to take advantage of approximately 90% of the disk's utilization, while the low priority database is limited to 5. So there you have it, 3 years of open source innovation, and you have a new way to control your resources in the cloud any way you want.